Today we are going to discuss about the radical detection in inorganic mixture. We have two types of radicals, that is anionic radicals and cationic radicals. For anionic radicals, it is very easy to find out them because we have only two types of groups, that are dilute sulfuric acid group and concentrated sulfuric acid group. For these radicals, we just have to put these radicals in contact of dilute H2SO4 and concentrated H2SO4, and with the observation we have to go for the confirmatory tests. But when we talk about the cationic radicals, we are speaking more scientific because the groups, that is from 1st to 6th, formed in the case of cations are very much scientific and systematic because they depends upon the term solubility product. It means that from 1st to 6th groups, the solubility products works, and on the basis of the solubility product only, we have characterized these in a group form. To detect the cations in a given inorganic mixture, we have to make, first of all, the proper original solution. There is a condition for original solution that it should be transparent and the mixture should completely be dissolved in that particular solvent. For making this original solution, one of the most important steps is to select the proper solvent. The solvents can be water, concentrated HCl, dilute HCl, and if all these three don't work, then we have to go for aqua regia. But generally we have to complete this in a range of water and HCl. So after preparation of the proper original solution that should be transparent, we have to go for the test of group first. How it can be performed? Just by addition of HCl in the original solution. If there is a appearance of precipitate, we can say that in a given inorganic mixture there is a presence of group first. It means that if group first, that is argentum, mercury and silver, are present in that given inorganic mixture, with addition of HCl they will form their chlorides in the form of argentum chloride, mercurous chloride and lead chloride, and as a result of which they will get precipitated out. So with addition of HCl, if precipitate appears, we can say that group first is present, and thus the group reagent for group first is HCl. Now, how to link it with solubility product? It means it is very elegantly clear that the chlorides of group first radicals are least soluble, and that's why they precipitate out first, they appear first. If they are more soluble, they would not be able to appear themselves. Now, what second group? What we have to do? We have to filter. Two. After filtering the precipitate of group first, we have the filtrate of first group to perform the test for group 2. In a filtrate of first group, add H2S in presence of HCl. Here we have to keep this in mind that when we are using this H2S to precipitate out the radicals of group 2, we have to supply H2S in less concentration, because the radicals of second group get easily precipitated out in presence of small amount of sulfides, and this is only the reason that with less and limited supply of H2S, we keep the presence of HCl, because due to the presence of HCl, because HCl is more ionic, it will produce its H plus ions in a high concentration, and as a result of which the phenomena of common ion effect will work, and due to the high concentration of H plus from HCl, H2S will not easily dissociate it in form of H plus and sulfides, and as a result of which less sulfide is available and the radicals of second group are very sensitive to sulfide. On these less concentration of sulfides also, they form their precipitates. Here we have to keep one thing in our mind, that we need not to supply H2S in higher concentration, because if you people will supply H2S in high concentration, you will create confusion, because at high concentration of sulfides, the radicals of group 4th will precipitate out. So keep this in our mind, that we have to supply less sulfides. The group reagent for group 2 is H2S in presence of HCl. And copper, bismuth, cadmium, arsenic, antimony and tin, they precipitate out in the form of their sulfides. If we get precipitate in second group, we have to repeat the same thing, that we have to filter it. After filtering, keep the precipitates for the characteristic and specific tests, and with the filtrate of second group, perform the test for group 3. To detect the presence of group 3, we have to add ammonium hydroxide in a filtrate of group 2 in presence of ammonium chloride. Group 3 consists of 3 radicals, that is ferrous, aluminium and chromium, and they can easily precipitate out if they are supplied with hydroxides in form of ferrous hydroxide, aluminium hydroxide and chromium hydroxide. Here also, the ammonium hydroxide is supplied in a filtrate of second group in presence of ammonium chloride. It is also very clear that if we supply ammonium hydroxide directly, then there would be the high concentration of hydroxides in a mixture, and thus as a result of which the ferrous, aluminium and chromium will not easily precipitate out. Because of the effect of common ion, when ammonium chloride is added, because it is more ionic than ammonium hydroxide, it will furnish more ammonium ions, and as a result of which there will be the less dissociation of ammonium hydroxide, thus easily precipitating out the radicals of group 3. After completion of this, we'll move and proceed to group 4th. Same we have to repeat. After filtration, keep the precipitate for the specific test, that is whether it is ferrous, aluminium and chromium. The filtrate of group 3, we have to perform the test for the presence of group 4th. The group reagent for the group 4th is H2S in presence of ammonium hydroxide, that is in alkaline medium, and group 4th is constituted by zinc, cobalt, nickel and manganese. They can easily be precipitated out in form of the sulfides if sulfides are present on higher concentration, and this is only the reason that while performing the test for group 4, we supply H2S in significant and good quantity, so that high concentration of sulfides should be available there. It can easily also be made due to the presence of ammonium hydroxide. In presence of ammonium hydroxide, because it is alkaline, H2S is acidic, it gets dissociated easily and it will produce high concentration of sulfides, and thus precipitating out the radicals of group 4 in form of hydrogen sulfide, zinc sulfide, cobalt sulfide, nickel sulfide and manganese sulfide. If precipitate appears here, filter the same, keep the PPT for specific tests, and with the filtrate of group 4, perform the test for group 5th. The group reagent for group 5th is ammonium carbonate in presence of ammonium chloride and ammonium hydroxide. Group 5th is constituted by calcium, strontium and barium. When we add ammonium carbonate, the calcium carbonate is formed. If it is present, if strontium is present, it will form strontium carbonate, and if barium is present, it will form barium carbonate, and they would be easily precipitated out. Group 5th is also known for its good flame tests. When we burn these ions and their precipitates in a flame with platinum wire, they produces the characteristic color like crimson red, brick red, and in the case of barium, it is apple green. When we move to the group 6, there is no common reagent. We just have to add sodium biphosphate and thus precipitating out the radicals of group 6. Now one radical is still remaining, it is ammonium. We consider generally in a form of 0 group. Never perform the test of ammonium at the end of these groups, because while performing the test of various groups, we continuously add on ammonium in form of ammonium chloride and ammonium hydroxide. So before moving to group first, we have to perform for test of group 0, that is for the ammonium. In a nutshell, we can say that these 6 groups are constituted and formed on the basis of solubility product, and this solubility product means those which have the less solubility, they will pip it out first, and those which have the high solubility, they will pip it out at the last, and thus we wind up with this concept.